Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and yes, we got one more video on this Powermatic 1150A drill press. It's kind of been the center of attention here in the Tin Barn for the last several videos, but I think we're going to wrap it up today with a simple little video. As I said in the previous video, what I want to do is replace this toggle switch with a much heftier on-off switch. Well, not that it's any more hefty, but it's something that can easily get to the power switch, kill power in a hurry if I need to. And as I did say in the previous video, looking at the pictures online, some of these were, it appears some of the Powermatics were shipped with a simple toggle switch here. Others with on and off buttons. Being this is from the mid to late 70s, actually 78 in particular for this model, I didn't really see any that had the emergency stop button, but this basically serves the same way. The only thing an emergency stop button does is you literally have to push it in and twist it to reset it. And once the emergency stop is triggered, you cannot turn it on until you reset it. This is a simple on and off with a big button on it. First thing we're going to do, I'm going to take this plate off. I've already got power turned off now at the breaker panel. But I'm going to take this off and take this plate right here and measure a piece of aluminum. I decided to keep this plate just in case I ever needed this piece of metal again. I've got some aluminum that is the exact width already. And like I say, I'm going to take this off, cut a piece to size on here, mark a couple holes in it, and drill those out. Probably do that off camera since it's such a simple task of the saw and 2 drill holes. But once I get that done, we're going to lay out what is necessary to mill out for the back of this switch. And that is primarily what this video is going to be about. I am not a licensed electrician. I have experience wiring switches and receptacles, but this is something that if you don't know how to do it, I do not want to encourage anybody to use one of my videos to try to show you how to do it when it comes to electrical. This stuff will hurt you if you don't know what you're doing. So if you're looking for a video on how to wire an on and off switch, this is not going to be the one. This is going to be about machining out the hole, mounting this, and then installing it back on the mill. So I'm going to get this piece cut and get some dicom on there, and then we'll meet over at the workbench and lay out the hole for this. Got the piece cut out, rounded the corners just a little bit over on the band or on the belt sander, and got the dicom, and it's dry. I think the first thing we're going to do is lay out the mounting holes. And this piece is not exactly square, so I think what I'm going to do is mate them up about as close as I can by eye, and then clamp them together. Alright, I think that's pretty good. Now I'll just set this up here on my little bench anvil. Take a transfer punch. This probably looks natural to y'all, but I'm left-handed and I'm trying to control this hammer with my right hand. Alright, that's got us enough of a mark. Alright, so Not that it matters, but I'm just going to mark that as the top. I'll put just a little indicator there too, in case one or the other rubs off. All right, now to lay this out in the center, I took the width of this piece, which is 3.294. I took the width of this housing here, which is 1.34, subtracted that from the 3.294, divided that by 2, and that gives me 977. I'm going to make it 975. So if we lay out 975 from each edge, and as long as I mill that line out, we'll be fine. Now the length on this is 5 1/4. The height of this is 2.76, so 5 1/4 minus 2.76 divided by 2 equals 2.49. Divide that by 2, and that's close enough. Let's see what it actually came out to. 2.49 divided by 2, 1.245. I'm obviously going to make it 1.25. All right, now there's going to be a little bit extra to do. This has a little ball sticking out the side over here, and the metal bracket over here is sticking out just a little bit on this side. So this will give us a rough start. Then we'll be able to drop this in and mark off for that extra boss that's on there. So let's turn over to the mill now and get set up to cut this section out of the middle. All right, I've got a 5/32 end mill in. And I'm going to start it out just a little bit into our line, and then I will plunge the end mill through this piece, set 0 on my DRO, come over here, and again taking out the lines each time, and hopefully this, I feel certain there shouldn't be any issue with cutting this full thickness 125 thousandths all at once. All right, that is through. All right, I'm going to set 0 on both axes there. Let's see. Little WD-40 maybe will keep the end mill from clogging up. All right, that's got to our line on that side. Lock the X-axis on the table. Unlock the Y. Now we'll lock the Y again, unlock the X, and go back in the other direction. I'm running this at 1120 RPMs too. Now I think with this size end mill, maybe I won't have to file those corners out. All right, this time we're going to come back to 0 on the DRO. Lock the X, unlock the Y, and go back to 0, or go back until our piece cuts out, which there it went. If anything, it should be small now. Yes, I need to take a little bit more out on 2 of the sides. Or we'll take a little bit out of the back and a little bit out over here. Not much, just a few thousandths. All right, there's 13 thousandths. May still need a little filing, but let's see. All right, it's bottoming out right there, but that's close enough that we can get to that boss that I said was sticking out on one side here. I'm probably making this hole a lot more precision than it needs to be, but why not? Needs a little bit more back here. I think what I'm ready to do now is on the bottom here, I need to measure this and lay out for the additional amount we need to cut out or mill out for this that's sticking out a little bit. You see on the top, it's actually flush. But on the bottom, well, get the angle correct. But on the bottom, it's sticking out just a little. So I'll lay that out and bring you right back. Okay, I took the faceplate off the switch, and it goes in fine now. As you can see, we got this little bit of standoff on the end down here. So I marked that right here. We'll put that back in the mill and mill out that little bit. It's right here, and it only goes in about 100 thousandths. And unfortunately, the only way to test that is to take it back out. All right, it goes in fine now. I'm going to go back over to the workbench and transfer these two holes right here. These are the mounting holes. All right, remember we laid out these corner holes before, which are the mounting holes to mount the whole assembly to the drill press. And I just laid out these two holes right here, which will mount the switch to this plate. The outside mounting holes will be 3/16. And these two holes will be 5/32. All right, I'm going to deburr this plate, clean up the die cam off of it, and then we'll mount the switch to the plate. All right, we've got our recess milled out. We've got our holes milled to mount the switch to the plate and the plate to the drill press. All right, now we got it lined up correctly. Got a hot washer and the nut. Looks like one of our lock washers has escaped. Well, if I if I had some green paint that matched the drill press, I would have painted that plate, but I believe it's going to be okay like that. All right, let's go mount this over on the drill press. All right, as I said earlier, I'm not going to try to provide a tutorial on how to wire an on-off switch such as this. Several reasons. Number one, as I said before, this stuff will hurt you. If you don't know what you're doing, get hold of a electrician, licensed electrician that knows what they're doing to wire your switch for you. Well, that's the primary reason, but another reason is that so oftentimes when you see a wiring tutorial on YouTube or online, it'll talk about wire colors. And those are not always consistent. This has been into before. That toggle switch that was on here before is a replacement. I know that from looking at it. It's a single pole double throw, meaning it's got a center position, a down, and an up. But only the up position was wired. Originally, I'm sure this was a single pole, single throw. And also, back here, this is the wire. You can see with my hand. This is the feed wire. This is the line in from the breaker box into this junction box. And from here, it goes over to the switch and back to the motor control itself. And these colored wires do not match what the feed wire is, the line wire. So color coding is not an option in here. I have identified which two of these are the line and which two are the load. And the switch clearly shows these two are the line and these two are the load. So I'm going to wire the two lines to this side and the two loads to that side. But I'm not showing you that because I don't want these colors to confuse you. One other thing I wanted to say too, I've put these stake-on connectors on here because that's the kind of terminal that's on the back of the switch. This is the tool I use to put the stake-ons with. And I ordinarily wouldn't even point out something like this. But I was in the Air Force stationed in Tucson, Arizona in the early 70s. And I used to go to the flea markets. They have a flea market on Saturdays or on the weekends over at the local drive-in theater. And I went to it several times, sold some few items there. But I went one day and there was a guy selling that had a 5-gallon bucket full of these crimping tools. They're actually Sure Stake brand. It says Sure Stake, stake-on hand tool, and it looks like it's made in Elizabeth, New Jersey. Thomas Bates Company. But anyhow, he had a 5-gallon bucket of these for 50 cents each. I wish I'd bought 2 dozen of them. But I bought one and I've had it for almost 50 years. And one of my go-to tools when it comes time to put stake-ons on the end of wires. All right, everything is wired up now. Let's see if our mounting holes match up. And it appears they do. All right, let's be sure it's in the stop position. I'll step in here and flip the breaker back on. No electrical shock. Let's see. All right, well there it is, folks. I'm going to call that an emergency stop. Well, I'm not going to call it an emergency stop or a panic button, but it is a stop button that's easy enough to get to should something go wrong. Much easier to get to flip off than this little toggle switch would have been. Hope you enjoyed that little bit of machining for this plate, and I'm sure you'll be seeing this drill press in use over the coming years, decades, as long as I last. So you guys take care, and I'll see you on the next video.